Okay, workplace 11, it's time to talk about angle of elevation. So, what are we talking about when we're talking about angle of elevation? The angle of elevation is the angle between the horizontal and the line of sight when looking up at an object. Boy, that sounds kind of confusing. Alright, so let's see if we can figure this out. The angle between the horizontal, well, if we look at this triangle, what's the horizontal line? The horizontal line is the one that runs along the horizon, right? This is the horizontal line there. And it says the angle between the horizontal and the line of sight when looking up at an object. So for example, if you were down here and you were looking up at an object that was way up here, you know, there's some kind of object right here that you're looking at. I don't know what it is, a ball. I'm such a good artist. Then the angle in between right here, this is the angle of elevation right there. By the way, this is supposed to be a right angle triangle, 90 degrees. All right, so here's what I want to do. I want to measure both of these sides here, okay? And then we'll talk about why in a second. So I'm pulling out the old trusty ruler again. Where is that thing? Here it is. So the first thing I want to do is measure the bottom here, and it looks like in millimeters it is about 94 millimeters right there. So let's record that. We have 94 millimeters. And then I'm going to turn this ruler, hopefully, yes, I'm getting better at this. And we're going to measure this height here. It goes from 0 up to 51, pretty well exactly 51. Okay, so 51 millimeters. Okay, so look at this. We got some information here. What could we figure out if we know this amount and this amount? We should be able to figure out the slope, right? This is what we've been talking about recently. What is the slope of this? Let's imagine this is a ramp here or something. What's the slope of that? Well, slope is equal to what? Rise over run. How much is the rise amount? The rise is the up and down, so it's 51 millimeters. The run is 94 millimeters. Hey, what do you know? We have the same unit. That's perfect. We can get rid of them. So we have a slope of 51 over 94. That's good. Tell you what, let's turn that into a decimal. How would you do that? You just take 51 and you would divide it by 94. And you get 0.543. I'm going to do 3 decimal places here. 0.543. That's the slope of this. Okay, that's great. We've done this before. You know, nothing new there. Here's the question we want to figure out, though. How could we figure out the actual angle of elevation? What if I wanted to know how much this angle was right here? Just with the information we have there. Either by using the rise and the run or using the slope, how could I get the angle of elevation? Well, you might remember this from previous course. What you would use is the tangent ratio. What's the tangent ratio? It's the ratio of the length of the side opposite from an angle to the length of the side adjacent to that angle. So if we look back here again at this triangle right here, if this is the angle we're interested in, the angle of elevation, what side is opposite from there? Well, it's kind of like if you came running out of that corner, right? If you there's a miniature little ant, you came running out of that corner, the one that's opposite is this one. This is your opposite right here. I'm actually going to write opposite. That's the opposite side. And which one's adjacent? Now, adjacent means right next to. So you could say either one of these are right next to that angle. But this longest side in a triangle, in a right triangle, you know what the longest side's called in a right triangle? It's called the hypotenuse, right? So if a side is a hypotenuse, it's not the adjacent. It's just the hypotenuse. So that's your hypotenuse, which means this one down here, this is your side which is adjacent. Okay, so what the tangent is a ratio, it's a comparison, and what you're comparing is two of these sides. The two you're comparing are, as it says here, you're comparing the opposite side, which we have right here, and the adjacent side, which we have right here. So if we wanted to get the tangent ratio for this particular triangle up here, why don't I write it down? You would have, hey, why'd that thing come back? Tangent ratio is equal to opposite, which is 51, over adjacent, which is 94. Wait a minute. 51 over 94, doesn't that look familiar? It's the same as the slope. So it's going to be exactly the same. It's going to be 0.543 again. Hey, what do you know? Slope and tangent ratio are exactly equal to each other. I never wrote that down, but it's kind of useful to put. Tangent ratio equal to slope. Okay. Here's a formula for you. Tan theta, that's theta, T-H-E-T-A, right? Just means unknown angle. The tan of an unknown angle is equal to opposite over adjacent, just like I have written here, opposite over adjacent. Okay, so now if we know the tangent ratio, 0.543, or we know the slope, 0.543, and we want to know the angle of elevation, there is actually a way to do it. What you do is you do inverse tan, kind of like the undoing the tan. So if I wanted to know the angle of elevation, it's getting kind of smushed here, isn't it? What I would do is I would do inverse tan of the 0.543. So here's where you'd need a calculator. So here's an example of something you might find. You can see here's tan, but we don't want tan, we want inverse tan. So on some calculators you'd use a button that says second, or it would actually say inverse, INV maybe. On this calculator I think you hit function, and you can see there it is, tan to the -1. That means inverse tan. And what we want to do is inverse tan of, what was it again? 0.543. So let's go ahead and put 0.543 in here. And here's the answer. I didn't even have to put equals in this thing. It's pretty good. The answer is 28.5, basically, right? 28.5 degrees. We got our answer that the angle of elevation is 28.5 degrees. We now know that this red angle right here is 28.5 degrees. Want to check it? Of course you do. You know how we do that? I amaze you again and pull out a protractor. So how's this work? We put this point right on the corner, right? So I put that point right on the corner, and now we can measure it. Here is 20 right here, right? And 21, 22, 23. Here's 25, 26, 27, 28, and there's 29 there. Look, it's right between the 28 and the 29. In other words, it is 28.5. We were right. We got the right idea just by using trigonometry. Tangent is part of trigonometry. Let's try a couple more of those. So we're going to find the slope and the angle of elevation, and actually we'll also get the tangent ratio. Okay, we'll find three things. So first thing we're going to find is the slope of this. So slope is equal to rise over run. The rise amount is 18, and the run amount is 50. Now you could keep it as a fraction, but if you're going to do that, make sure you put it in lowest terms. You could divide them both by 2. You get 9 over 25. If you're going to put it as a decimal, you would just do 9 divided by 25, and you get 0.36. Okay, so there's your slope. Now let's get the tangent ratio. Now again, if you're understanding this, you should be done already, because tangent ratio is equal to opposite over adjacent when we're looking from the angle of elevation. So where's the angle of elevation? This is our angle of elevation right there. Right? There's the angle of elevation. So the opposite angle from there, if we come running out of there, the opposite is 18. And the adjacent, remember, not this one, that's hypotenuse. The adjacent is down here, it's 50. Hey, what do you know? It's exactly the same, right? We said this will always be the case. Slope and tangent ratio are always going to be exactly the same, so I get 0.36 again. Now, if we want to know how much the angle of elevation is, if we're actually interested in this angle right here, which I could call theta, that's what we often call it, then what I would do is I would take inverse tan, that means inverse tan of the 0.36. And then we'll have to go to our calculator. So inverse tan of 0.36. So here we go. Inverse tan, look at it stayed on this calculator, it stays. In most calculators, it would revert back to this again, and you'd have to hit again second or inverse or whatever. But just make sure you get this inverse tan with a -1, and we said it was what, 0.36? So then I'll type in 0.36, and we get our answer. It's 19.8. I'll round it to 8. 19.8 degrees. Don't forget, we're getting an angle, so make sure you put degrees. 19.8 degrees. So we now figured out that the angle right there is 19.8 degrees. We have our 3 answers. Okay, let's do it one more time over here. So the slope is equal to rise over run. The rise is the up and down amount, that's 42. The run is the sideways amount, 28. You could divide those both by 2 and get 21 over 14. Oh, actually, you could have divided them both by 14. I didn't recognize that, but I now recognize I could divide both of these by 7. So I get 21 divided by 7 is 3, and 14 divided by 7 is 2. So I get 3 over 2, which is actually equal to 1.5. That is my slope. Okay, tangent ratio, again, this should be dead easy. Because, whoops, tangent ratio is opposite over adjacent. I'm just going to put op and adj. And where's the angle of elevation in this particular one here? Oh, sorry, right angle here, right angle here. Where's the angle of elevation? It's here. This is the angle of elevation. Okay, so what side is opposite from there? If I came running out of there, I would hit this side here, which is 42. Which one's adjacent? Not this one, that's hypotenuse. This is adjacent, 28. And look, once again, it's exactly the same as up here. So again, you're going to get 1.5. So we're now ready to get the angle of elevation. How do we do that? We're going to do our inverse tan of the 1.5, right? It's going to be inverse tan of either the slope, if you want to put it in there, or inverse tan of the tangent ratio. Either one works. Since slope and tangent ratio are exactly the same, you can use either one. Okay, back to the calculator for inverse tan of 1.5. Okay, so inverse tan of 1.5, and we get 56.3. I will not forget my degrees, so 56.3 degrees is our answer. And we're done. Slope, tangent ratio will always be the same, and here's our angle of elevation. All right, a couple more questions. Brad needs to unload a quad from the box of his pickup truck. Yeah, Brad. He places an aluminum ramp against the truck bed at a slope of 7 to 40. Now that's strange. We don't usually give slope in this way, but you can. Remember, slope's a ratio. So this is just the same as saying slope is 7 over 40, right? What's the angle of elevation to the ramp? All right, so hopefully you can picture this. He's got his truck. How am I going to draw this? I'll draw it like this. I mean, that's probably a bit much, but he's got his truck here. Here's the back of his truck. I cannot draw anything, but there's the back of his truck, right? Here's his big wheels there. Okay, let's not. Okay, that's ridiculous. So here's our ramp, and the slope is 7 to 40. Now, my ramp isn't even close to 7 to 40, but it doesn't matter if it's drawn correctly. You can still label it correctly. Remember, if it's slope, what's the top number refer to? Rise. And what's the bottom number refer to? Run. Okay, so in our ramp right here, where's the 7 go? Right here for the rise, right? And the 40 goes right here. And what you need to do is figure out what's the angle of elevation. Well, this is the right angle. This is the angle of elevation. That's what we want to find out right there. How are we going to do that? We're going to start by either figuring out the slope, or we're going to figure out the tangent ratio. Because remember, they're equal to each other. So the slope and the tangent ratio are exactly the same. So why don't we do slope? Well, wait a minute. It gave us the slope. The slope is 7 over 40, right? If you're doing the tangent ratio, opposite is 7, adjacent is 40. So we have the slope, we have the tangent ratio. Remember what we always did to get the angle of elevation? We just took that amount and we did inverse tan of that amount. Now, what you might want to do first is figure out what 7 over 40 is a decimal. Might be a little bit easier if you get it as a decimal first. If you do that, don't write it to one decimal place. Do it to 2 or 3. Actually, turns out it's exactly 0. Whoops. It's exactly 0.175. Put all those decimal points. Don't just put 0.1. Your answer is going to be quite a ways off. Even if you round properly to 0.2, it's still going to be a little ways off. Put at least 3 decimal places. So 0.175. So in order to get the angle of elevation, I need to find inverse tan of 0.175. So we'll go to our calculator and do that. Inverse tan of 0.175. Inverse tan of 0.175, and I get 9.9 degrees basically. And that's it. 9.9 degrees. So we know that this angle right here is 9.9 degrees. The angle of elevation is 9.9 degrees. Okay, last question. It's a long one, like to read. It's not too long to do, but it's a little bit long to read. The type of roofing material used on a house depends on the slope of the roof. So if your roof is steeper, has a higher slope, you might use different materials. The table below shows 3 types of roofing material and the slope of roof each is suited for. So if your roof isn't slanted very much, it only has a slope of 0 to 14 degrees. Sorry, an angle of elevation of 0 to 14 degrees. You might use tar and gravel because it makes a watertight seal. If it's more than 18 degrees, you could use asphalt shingles. They shed water, but they're not watertight. If it's more than 26 degrees, it's really steep, you could use clay tiles, which also sheds water, but it's not watertight. So there's these 2 families, the Cardinals and the Sebastians, and they're building houses, and they need to just decide, what are we going to put on our roof? So we're going to help them out. So for A, the Cardinals' roof has a rise of 3, what's that little mark mean right there? That means feet. 3 feet, and a run of 18 feet. So again, we're always going to have these right triangles. That's what it's always going to be looking like in today's work. So it has a rise. Well, the rise is right here, so this would be 3, and it has a run of 18. And we're interested in what's the angle of elevation. Here's our angle of elevation right here. Right? There's our theta, our unknown angle. So how are we going to figure out that angle? Same as what we've done all these questions. The first thing we have to do is find the slope, which is going to be equal to the tangent ratio. Well, slope is rise over run. 3 over 18, you could put that in lowest terms, divide them both by 3, you get 1 over 6, and 1 over 6 is a decimal, is 0.1666, just keeps going on and on with the 6's. Okay, so now we can get the angle of elevation. How do we do that? You take that slope, or the tangent ratio, and you do inverse tan of it. So you're going to do inverse tan of 0.1666. Put a bunch of 6's in there. Okay, so let's go to our calculator and do that. Inverse tan of 0.16666. Inverse tan of 0.16666. As I put more 6's, it's getting more and more exact. Oh, it stopped. You can see I love this calculator. It stopped right there. So I know my answer is 9.46. I could round that to 9.5. So 9.5 degrees is our answer. And so now we can tell this family, the Cardinals, which one of these roofing materials should they use. Well, 9.5 degrees is right in this area here. It's between 0 and 14. Don't use this. It has to be more than 18 or more than 26. It's right in there. So they're going to use tar and gravel for this family. Okay, now let's do it for the Sebastians. Same sort of idea. They've got their roof here, makes a right angle, has a rise of 6 feet, has a run of 16 feet. So now we can get the slope, which is equal to the tangent ratio. Oh, where's the angle of elevation? Right here. That's what we're trying to find. So slope, rise over run, or if you want, tangent ratio, opposite over adjacent. So 6 over 16, can divide those both by 2, you get 3 over 8. It's nice to put it as a decimal. So 3 divided by 8 is 0.375. Let's put down all those numbers so we got a nice exact answer. So now to get the angle of elevation, we take the slope, or the tangent ratio, because they're the same, and we're going to do inverse tan of that amount, 0.375. Go to the calculator. Inverse tan of 0.375 is equal to 20.55 rounds to 20.6. So 20.6 degrees is our answer. Good job. Last thing, if it's 20.6 degrees, where does it fall into? Well, it's too steep for the first one. It's not steep enough for the last one. It has to be more than 26, but it's perfectly right in here, right? Between 18 and 26, yeah, ours is 20.6. So we should be using asphalt shingles. Asphalt. Such a hard word to say. Asphalt shingles. So we'll write that down, and we are done this video. And I hope it makes sense. Angle of elevation and the tangent ratio. All right, everyone, take it easy.